Hello everyone. So this is your pre-calculus module. First lecture note, fundamental concept of algebra. So first of all, we need to see what is the real numbers and their properties, right? You already deal with these real numbers. Real numbers in Sinhala name, Tatika Sankhya. Real numbers are used in everyday life to describe quantities such as age, miles per gallon, and population. So you already deal with these real numbers, right? So here there are some symbols to represent the real number. So you can see here -5. So that means there is negative sign also included. And here 9. So that means positive value. And 0. And fractions 4 divided by 3. And also that infinitely many decimal places like 0.666 and continuously it's going on. So here there are 3 dots. That means that continuously going on, right? And limited decimal places 28.21 and square root 2, 5 and this one. Okay. So let's move to next part. Here there are some kind of that we can divide to divide these real numbers. Okay, some important subset of real numbers. So set of natural numbers. Natural numbers 1, 2, 3, 4. Here you can see 3 dots. We call ellipsis point. So this one indicates the pattern continuously, indefinitely, right? And set of whole numbers. Set of whole numbers here that 0 include. You can see the difference between natural numbers and whole numbers, right? Whole numbers mean Purna Sankhya. So 0 include whole numbers, but natural number there is no 0, right? Then set of integers. Integers you can see here minus value and negative value and positive value both include, but whole numbers. So integer mean minus, negative or positive whole numbers. Dhana ho rina Purna Sankhya. Here there is no any decimal places or otherwise fraction numbers, right? Fraction part. මේකට භාග හෝ දශම අයිති වෙන්නේ නැහැ. Only whole numbers. පූර්ණ සංඛ්‍යා විතරයි. ධන හෝ ඍණ. Positive or negative whole numbers, right? Okay, let's move to next part. The set of real numbers includes the rational numbers and the irrational numbers. So we know that real number, there are two types of, we can divide two groups, rational numbers and irrational numbers. Right? So here, a real number is rational if it can be written as the ratio P divided by Q of two integers, where Q does not equal 0. Right? So that means if a real number is a rational number, we can write this number in a form of ratio, right? So that means P also, that ratio of two integers. This one also, P also integer, Q also integer, right? And here Q does not equal to 0, right? So you can see here there are some examples. 1 divided by 3. So this one equal 0.33. That one goes to infinitely many numbers. But there is a pattern in here, right? Always 3. Continuously it's going on. So we can write this one as 0.3 bar. So if we put this one, or sometime we put 0.3 dot, or otherwise this bar dot in here, right? So this means this one continuously going on, right? Other one is 1 divided by 8. So this one equal that 0.125. So there is endpoint here at only this values 0.125 and 125 divided by 111. So that means this one equal 1.126, 126, then again 126. Okay. So here also we can put that dots. So, and also we can write this one as 1.126 bar. So this bar means this one continuously going on. Or otherwise we can write 1.126 and we can put here dot sign and here dot sign. So this one also mean we know that this one continuously going on. This pattern 126, 126, right? So this type of numbers we call rational numbers, right? Okay, let's move to next part. Irrational numbers. A real number that cannot be written as the ratio of two integers is called irrational. Irrational numbers have infinite non-repeating decimal representation. So do you understand? Rational number, we can write that one as a ratio of two integers. මෙන්න මේ විදිය අනුපාතයක් විදිහට අපිට rational numbers ලියන්න පුළුවන්. But irrational numbers we cannot be written as the ratio of two integers. Right? මේ irrational numbers වල අපිට බෑ ඒක අනුපාතයක් විදිහට. කියන්නේ integers දෙකක අනුපාතයක් විදිහට අපිට ලියන්න බෑ. ඒ කියන්නේ irrational numbers have infinitely non-repeating decimal places. Decimal representation. Non-repeating. Here infinitely, that here infinitely many values, but there is a repeating. We know the pattern, but here there is no any pattern, so that means non-repeating, right? So we can see these examples. Square root 2, we know that the value of square root 2 equal 1.4142135. That one goes infinitely, and here there is no any pattern, so that means non-repeating, right? So approximately equal to, we call for this sign as approximately equal to. ආසන්නව සමාන වෙනවා කියලා කියන්නේ. If we use this equal sign, that one means exactly equal, but this one means approximately equal. ආසන්න වශයෙන් සමාන වෙනවා කියන එක. So square root 2 approximately equal 1.41. And also we can take 5 also as irrational number because the value of 5 equal 3.1415926. So here also there is no any pattern, that means non-repeating decimal representations. Therefore, this one also irrational number. So we can write this one as approximately equal to 3.14, right? Okay. Here you can see the graph, right? So real numbers. These all are real numbers, irrational numbers and rational numbers. These all are real numbers, but that this blue color one, that this whole value, this whole value subset of rational numbers, right? Integer also belongs to rational number, whole numbers also belongs to rational number, natural numbers also belongs to rational number. But integer, there is no any fraction part or decimal numbers. Therefore, integer means positive or negative whole numbers, right? So this one integer. Then we can divide that one into whole numbers, because whole number we know that only positive values. Positive values mean positive integer including 0. But in here natural number we know that there is no any 0 here included, right? And irrational numbers, we know that pi, e, and square root of 2 exponential. We know that this e means exponential, right? Okay, then let's move to next part. Here you have one example, classifying real numbers. So determine which number in the set are, here you have their number set, minus 13, minus square root 5, minus 1, minus 1 over 3, 0, 5 over 8, square root 2, 5, and 7. So we need to determine what are the natural numbers, what are the whole numbers, what are the integers, and rational numbers and irrational numbers. Okay? Okay, let's do this one. So natural numbers. What are the natural numbers in here? Natural numbers only 7, right? Because we know that 0 is not included to whole natural numbers, right? Here you can see natural number means 7. Then whole numbers. Whole numbers mean 0 and 7. Then integers, positive or negative whole numbers. So here whole numbers including only positive integers. Integers, positive or negative whole numbers, right? So minus 13 and minus 1, 0 and 7, right? Then rational numbers, minus 13, minus 1, minus 1 over 3, 0, 5 over 8, and 7. Irrational numbers. Here, 5 also, square root of 5. You can check the value of square root of 5. So, the value of square root of 5 approximately equal to, so this value approximately equal to 2.360679777. Likewise, there is no, we unable to find the pattern. Therefore, square root minus square root 5 also irrational number. And also we already know that square root 2 and pi also irrational numbers, right? Okay, let's move to next part. Okay, here you can see real numbers are represented graphically on the real number line. I think you already know the number line. So we know that the real number we can represent it in a real number line. ඒ කියන්නේ මෙන්න මේ real numbers අපිට පුළුවන් number line එක පෙන්වන්න graphically පෙන්වන්න එක පුළුවන්. When you draw a point on the real number line that correspond to a real number, you are plotting the real number, right? The point 0 on the real number line is origin. So the point 0 is the origin. Number to right of 0 are positive. Numbers to right of 0 positive, and numbers to left of zeros are negative. So 0 is the origin, that point, and numbers of right of 0 are positive. මෙන්න මේ 0 වලින් දකුණු පැත්තේ තියෙන සියලුම values ටික අපි කියනවා positive integers කියලා. මේ වම් පැත්තේ තියෙන ටික අපි කියනවා negative values, negative integers කියලා. So here 0 positive integers, here negative integers. These are integers, right? But we can't, that inside we have some values, no? So we can't tell integers, right? All numbers. Correct numbers, not integers, numbers. I think it's better. Numbers, right? Yes, so numbers. Because we know that integer means positive or negative whole numbers, right? Okay, here you can see 0.2. So we know that in between 0 and 1, the 0.2 should be. So in here. And minus 3 over divided by 2. So we know that that one in left hand side of 0. So in here somewhere point, right? Minus 3 divided by 2 mean approximately this one equal to minus 1.5, right? So in between the middle point of 1 and 2, minus 1 and minus 2, right? The next one is square root 2. So we know that this value approximately equal to 1.41, right? 0.14. We already are here 41. So 1.41. So something here 14. Yeah, 41. Right. And also here you can see minus 3 half. So minus 3 and half. So something here. And here also half. So that means in between 0 and 1. Right? And here 4 half. So in between 4 and 5. 4 half in here. Right? Okay, example 2. Plotting points on real number line. Plot the real numbers on the real number line. Okay, I think you can do this one, right? Here, these are very simple examples. So minus 7 over 4. Minus 7 over 4. That one should be in here somewhere. Then next one, 2.3. 2.3. So minus 7 divided by 4 means 7 divided by 4. So that one approximately equal to, no, that one equal to 1.75, right? Minus 1.75, right? Minus 1.75. So in here somewhere. Then next one, 2.3. 2.3. 2 divided by 3. So somewhere here. Then next one, minus 1.8. We already marked 1.75. So 0.5 in here, right? Minus 1.8. So you can see the point representing the real number minus 7 over 4 equal to minus 1.75 lies between and but closer to minus 2 on the real number line, because this one minus 1.75. So that one closer to 2, right? The point representing real number 2.3 lies between 2 and 3 but closer to 2. The point representing the real number 2.2 divided by 3 equals 0.666. This one lies between 0 and 1 but closer to 1. The point representing the real number minus 1.8 lies between minus 2 and minus 1. So minus 2 and minus 1, but that one closer to minus 2, right? Okay, next we have to discuss order in real numbers. So I will discuss order in real numbers in next video, right? So I will stop this video and we will meet from the next video, right? Okay. Okay. In this video, we will discuss ordering real numbers. One important property of real number is that they are ordered, right? So definition of order on the real number line. Let's see definition of order on the real number line. So here you can see if A and B are real numbers, A is less than B. A is less than B if B minus A is positive. So here A is less than B means B value is higher value. Okay. So A is smaller than this B value. Therefore, we know that this one is highest value, this one is large value, this one is small value. So if we reduce from a small value from the large value, we know that this one is positive, right? The order of A and B denoted by inequality A less than B. I think you already know this sign, A less than B. So that means A කුඩයි B විශාලයි. අපි දන්නවා විශාල පැත්ත තමයි අපි සිංහලෙන් කියද්දි කියනවා කට අරගෙන ඉන්න පැත්ත කියලා. So here if A is less than, if A and B real numbers and A is less than B, then B minus A is positive, right? We can write as an inequality A less than B. This relationship can also be described by saying that B is greater than A. And also we can say this one, B is greater than A. If we write this way, then we can tell B is greater than C. So we know that this side is greater side, this one is less side. So B is greater than A. Or otherwise we can call A is greater than B, right? The inequality A less than or equal B. So we know that this symbol means A is less than or equal. If we have this sign, we call that one as less than. But if we have this line, this one, we call less than or equal, right? And then inequality B greater than or equal A means that we call, if we have this sign, then we call that one as B greater than or equal. This one A less than or equal B. This one is B greater than or equal A. Okay, normally we read in left hand to right hand side. This side to this side. Okay, so here also this side to this side. So we can see then what is the first side you will meet here? This one. So this one means less side. This one is greater side. Therefore, we can tell A is less than or equal B. Here A is less than B. But in here, this one is greater than side. So B is greater than or equal A. Otherwise, B is greater than A. Right? Okay. The symbols and are less than, we call this one as less than, then greater than, less than or equal, and greater than or equal are inequality symbols. So these are the inequality symbols, right? Less than, greater than. Normally we read this one, this side to this side. Okay, this side to this side. Right. Let's move to next part. Geometrically, this definition implies A less than B if and only if A lies to the left of B on the real number line. A lies left of B. So if A less than B, then A lies in left of B. ඒ කියන්නේ A කියන එක නම් B ට වඩා කුඩයි නම් A ඉන්නේ B ගේ වම් පැත්තේ. මේ පැත්තේ. එතකොට A විශාල වුණොත් A ඉන්නේ B ට දකුණු පැත්තේ. Right? Okay. So here you can see some example ordinary real numbers. Place the appropriate inequality symbol less than or greater than between the pair of real numbers. So here -3 and 0. We know that -3 less than 0. Therefore this sign. And -2 and -4. -2 and -4. So we know that -2 in here somewhere. Then -4 means here somewhere. So -4 in this side to -2. So that means -2 is less than. If we consider -2 here, then left hand side of -2, right? -4 lies between left hand side of -2, right? Therefore -2 is less than. Do you understand? ඔයාලට මෙතන පේනවා -2 කියන එකනට වම් පැත්තෙන් තමයි -4 තියෙන්නේ. එහෙනම් කවුද අඩු අගය? -4. Here you can see. If this definition implies A less than B if and only if A lies to the left to B. A lies to the left to B, right? Then considering this one, 1/4 and 1/3. What is the value of 1/4? 1/4 means 0.25, right? This one equals 0.25. 0.25. Then what about 1 over 3? 1 over 3 means 0.333. That continuously that one is going on, right? 3, 3, 3, 3. Then which one is the greatest value? We know that 1 over 3, right? This one. So this symbol should be like this way, right? Then considering these two, 1 over 5 and 1 over 2. 1 over 2 means minus 0.5. Then minus 1 over 5 means minus 0.2. Right? So that means we know that in a number line, 0.5 in somewhere here, then minus 0.2 in somewhere here, and 0 here. So we know that minus 0.5 lies left to the minus 0.2. Therefore, this one is less, this one is highest value. So, this symbol, right? Okay, then let's move to next part. Here you can see the answers, right? Here, minus 3 lies to left to the 0 on the real number line. So, we can say minus 3 less than 0. And we can write minus 3 less than 0. And similarly, minus 2 lies to the right of minus 4 on the real number line. So we can say minus 2 is greater than minus 4. So using this symbol. And next one, 1 over 4 lies to left of 1 over 3 on the real number line. So we can say 1 over 4 is less than 1 over 3. And we can write this way. Similarly, this one also. Right? Then next example, interpreting inequalities. Describe the subset of real numbers represented by each inequality. X less than or equal to. Then part B, minus 2 less than or equal x less than 3. So we can describe this one as the inequality x less than or equal to denotes all real numbers less than or equal to 2. So this one denotes all real numbers less than or equal to 2. Okay, less than or equal to. So we can draw number line, and less than or equal mean this bracket, right? Then part B, the inequality minus 2 less than or equal x less than 3 means this x greater than or equal minus 2 and x less than 3. So this double inequality denotes all real numbers, all the real numbers between minus 2 and 3, including minus 2, but not including 3. So this one means minus 2 include, but my 3 is not include. Therefore, we can write this one here, square bracket, here this one, parenthesis. We call this bracket as parenthesis, right? This one is square bracket. So this one means if we use this bracket, we go that, then that means that value also include. But if we use this bracket, that means this value is not include. Right? Like here. Here also same way. Here x less than or equal to, so that means this value included, right? Okay. Inequalities can be used to describe subset of real numbers called intervals. So those inequalities, this one we can say as a intervals, right? We can So we call that one as intervals. In the bounded interval and real numbers a and b are the endpoint of each interval. So if our interval is bounded, so that means endpoint. One is starting point, another one is endpoint. So those are the endpoints. Okay. So minus 2 and 3 are the endpoint of each interval. We call this one as interval, and these two are endpoint, right? The endpoints of a closed interval are included in the interval, whereas the endpoint of open interval are not included in the interval. So that means closed interval. We call this one is closed interval. If that interval is closed, so that means that value include. But if that one is open bracket, so that that value is not included to that interval. Do you understand? So here, this one closed interval, this one open interval, right? If we use this bracket, we call this one as close bracket, close bracket. And this bracket means open bracket, open interval. So if we use this one, so for here, so that means that value does not include. But if we use open bracket, so that means that this value is include to interval, not include to interval, right? So there are two types of intervals. One is bounded. Okay, you know that interval we can divide two types of interval. One is bounded interval. Bounded interval. Other one is unbounded interval. Okay, other one is unbounded. So first of all, let's see what are the bounded intervals on a real number line. Okay. So we know that if we have this one, we call this one as the interval. Okay. So notation, here we use the square bracket. So that means both are closed. So we call that this interval is closed interval. And in equality sign, A less than or equal X, less than or equal B. In graphically, we can draw here A with this bracket and B also this bracket. So we know which one is the endpoints. Therefore, we can show this one and this one are endpoint. So this one is bounded interval. And similarly, if we use this notation, so this bracket means open bracket. Okay. If we square bracket, close bracket, then we call this bracket as open bracket, right? So that means this interval is open interval. In notation, we can write both are not included, right? A and B values not include to this interval. Therefore, A less than X less than B. So we can graphically mention this way. And here, one side is closed, other side is open, right? One side is closed, other side is open. Therefore, we can write in inequality form A less than or equal X less than B, right? This one means equal. A less than or that one means here A include to this interval, but B does not include to this interval, right? So in graphically, we can write this way. And here open interval, here close interval. In notation, we can write A less than X less than or equal B. In graphically, A with this bracket and B with this bracket, right? Now let's see what are the unbounded intervals. Okay, first of all, before that one, okay, here you can see interval notation, that earlier one, AB. So interval type closed, and inequality notation this one, and graphical way, we know that if this one include, if this one equal A less than or equal, then normally in here we draw a circle and color that one, right? But if this one open, So here there is no equal sign. We just draw a circle. You can see this one color dot, but this one without coloring, just a circle. So that means this value A does not include to this interval, right? And also B value also not include to this interval. And if we have this notation, we call this one as half open, right? So we can in equal notation this one like earlier way, and graphically we know that this one equals, so that means A value include to this interval but B does not include. So here just draw a circle and color. Here without coloring, just a circle, right? And similarly, this one also. We call this one also half open. Then B is closed. Therefore, here draw a circle, color that one. Here without coloring, right? Okay, now let's see what are the unbounded. Oh, before that one, there are some examples, right? Okay, here you can see this one is closed. Draw a circle and closed. Here just a circle. So that means open interval. So here 0 with this bracket and 3 with this bracket, right? And notationally you can write 2 less than or equal x. Here less than or equal 6. Otherwise this notation you can use. And here 2 less than x less than 6. And with this bracket 2 comma 6. And here 2 less than or equal x less than 6. And here this bracket 2, and here this one is open interval, therefore 6. Here 2 less than x less than or equal 6. So just a circle, here colored one. And notation here with this bracket and here a square bracket, right? The symbols for, we know that this notation means infinity. So if we have this one, we call positive infinity. If we have negative sign, so we call that one as negative infinity. The symbols positive infinity and negative infinity do not represent real numbers. So if we have infinity symbol, that positive infinity or negative infinity symbol, we know that that one do not represent real numbers. They are simply convenience symbol used to describe in the unboundedness of an interval, such as 1 comma infinity or minus infinity comma 3. So normally if we have infinity sign, so we normally use this one for describe unboundedness, right? If we have infinity sign, so we call those intervals are unbounded, right? And we know that normally for the interval, we use parentheses, not square bracket. Always for the infinity, negative or positive infinity, always we use parentheses, right? So here you can see unbounded intervals on the real number line. Here a comma infinity. So if we have infinity, so we unable to mark that point in the number line. Therefore, we call this one as unbounded interval, right? So here x less than or equal a. So we know it's starting here, and we don't know where is that one in. That one goes to infinity, right? So we call this interval as unbounded. And here a comma infinity. So we know that this one is open interval. So x greater than a. So starting here, that one goes to infinity, right? And here negative infinity to b. So we can write x less than or equal b. So we can graphically write like this way. And this notation negative infinity to comma b. So this one also open interval. So x less than b. So we can do graphically like this way. So if we have negative infinity to positive infinity, so that means entire real line. Negative infinity to positive infinity, right? So these intervals we call unbounded, right? Okay, let's move to next part. Here you can see interval notation and interval type is closed interval type. Here you can see the closed bracket, therefore closed interval type. So inequality notation x less than or equal a, and graphically here we know that draw a circle and we need to color that one because here we have equal sign and here this one is a closed bracket, right? If we have this one, that means open interval. So x greater than a. Just draw a circle without coloring, right? Then next one, negative infinity to b. Negative infinity comma b. But here b is closed. And we can write x less than or equal b, right? So we can draw this one. The next one is negative infinity comma b. So we know that this one is open interval. So x less than b, right? Then draw a circle. Don't color that one without coloring to this way because negative infinity. This one goes to negative infinity, right? So all these intervals are unbounded, right? Next one, there is an example interpreting inequalities. Give a verbal description of each interval. So here we have minus 1 comma 0, 2 comma infinity, minus infinity comma 0. So we know that for this interval consists all the real number that in between that are greater than minus 1 and less than 0. Okay, so if we draw a number line, we know that minus 1 here and 0 here, right? So in between these two, these all the values, right? So that means the interval consists of all real numbers that greater than minus 1 but less than 0. What about this one? This one means this consists all the real numbers that greater than 2, greater than or equal to, right? Here you can see this interval consists of all real numbers that are greater than or equal to. If we draw a number line, then here we can mark 2 and with this bracket, close bracket, right? Then this side, you can color. Otherwise, I will draw this in another color. This side, right? That one goes to infinity. Considering this one, this consists all the real numbers that are less than 0. If we 0 here, then open bracket, right? Not close bracket. Okay, we just draw a circle, right? And this side. Okay. So this interval consists of all negative real numbers. So we know that 0 here, then left hand side of 0 means all the negative values. Okay, that is the end of this lecture note 1. So there are some, I already uploaded this lecture note to the LMS. Please study that one. Okay, thank you.